Okay, so as in the last video, we have derived the formula for finding the or for calculating the radius of orbits, right? In today's video, we're gonna solve some problems that I've taken from the KPK board book. So as you can see, this is an example. This is not practical problem or practice problem. However, this is an example. Calculate the radius of third and fourth orbits of hydrogen atoms. Now either you can use that derivation which we did, which was n square h square epsilon naught upon pi m z square, or you can use the shortcut as well, right? If you are gonna use this formula, how you're gonna use this, right? So you're gonna write n square h square epsilon naught upon pi m z square, right? This was for finding radius, or I should write a bit there. This was for finding radius, right? Instead of n, you can write the shell number. Here we have what? It is 3, right? So 3 square h, the value of h we have is 6.625 into 10 to the power minus 34 joule, minus 34, and h square, so we have to take the square of this whole value, right? Epsilon naught value is equal to 8.85 into 10 to the power minus 12, right? So I've written here as well, upon, now pi value is constant, which is equal to 3.142, into mass of electron is constant, which is equal to 9.11 into 10 to the power minus 31 kg, right? Minus 31, and atomic number of hydrogen is 1, right? So here we're going to write 1, and then E square, which means charge of electron, which is equal to minus 1.67 into 10 to the power minus 27, right? E square we have, right? So square of this whole term. When you're gonna solve this, you're gonna get, I'm writing directly the answer of this, right? We're gonna get is 4.77 Armstrong. This is not an approximate value, however this is an estimated value. You can calculate, right? So if you're not going to use this formula, right, this is a bit lengthy, and I have told you guys a shortcut as well. Wait, let me highlight this first. Let me highlight the formula as well. Here we have formula, right? So here we have formula, and we have taken out the answer from this, right? Now we're gonna solve from the shortcut method, right? Now we know that we have the formula n square h square epsilon naught upon pi m z square. Let's separate the constants first, right? Let me write here by shortcut now. By shortcut. By shortcut. So we have to separate the constant. So n square is the not constant, since n is the shell number which will be changed. H square is constant, epsilon naught is constant, upon pi is constant, mass of electron is constant, atomic number is not constant, however charge of electron is constant, right? Into n square is not constant, and z is not constant, right? So now this whole value or whole constant term was equal to 0.5, 0.53, right? Or 0.29, 0.529, or you can write 0.53. Thus we got 0.53 into n square by z, right, is equal to radius. So this was our shortcut formula, which we're gonna use this now, right? So let me highlight this as well. Okay, let's take this color. Here we have solved this with the shortcut method, and here we got our shortcut formula, right? So now let's solve with this formula. Let's solve with this formula. Now 0.5 will gonna remain same, right? Calculating. Zero 0.5 will gonna remain same and represents the shell number. Here we are gonna find the third one first, right? So n square means 3 3s are 9 upon z, atomic number, and the atomic number of hydrogen is 1, right? So 0.5 into 9 is 4.77 Armstrong. This is an answer, or radius of third orbit of first atomic number of hydrogen, right? So this is an answer. This is an answer, right? Now let's calculate for the fourth orbit. Here we're gonna calculating for fourth orbit. Same 0.53 into 4 4s are 16 upon 1. When we solve this, we got 0.53 into 16, we got 8.48 Armstrong. There is a radius for the fourth orbit of hydrogen atom. Right? So let me highlight this. Let me highlight this as well. The value. Alright, so we have solved our first problem. Now let's go and solve the second problem. Calculating for the fifth orbit of hydrogen atom. Right here you can see, wait. Here you can see. So 0.53 into 5 5s are 25 by 1, right? Because the atomic number of hydrogen is 1. Radius of fifth orbit. So when you multiply 0.53 into 25, you get 11.25 Armstrong. So we have found of the fifth orbit as well. Let's calculate the last one, which is for the sixth one. 0.53 into 6 6 are 36 upon atomic number 1. 0.53 into 36, you get 19.08 Armstrong, and this is the radius of sixth orbit, right? So in the next video we're gonna derive the formula for the velocity of electron in the shell.